Welcome to end-to-end email spam ham detection project. End-to-end project means what is shown in this architecture here. Normally, many new students in the data science, they think that the data science business is only this much. Take raw data ingestion, do exploratory data analysis, develop a model, and then use that model. But actually speaking, that is only half the journey. After you use the model, after you develop the model, if it remains in your laptop, then it is practically not useful. But you have to deploy it somewhere. So model deployment is the next stage, for which you have to develop some back end, you have to develop some front end, which requires knowledge of back end and front end engineering. So originally, up to the model development, that part was handled by data scientists, while after deployment and the remaining part, that were handled by data engineers. But in today's tough job markets and with advent of AI, companies expect that there should be full stack data scientist who knows everything and who does everything. Even if that is not the case, the data scientist and the data engineer, if they both know about each other's craft, then the data project can be completed very quickly and with minimum friction between them. So here, this is the model deployment. In our case, we will be using Streamlit for it. Even there, 75% of the journey is over, because once the model is deployed, and suppose initially it is delivering very good business value, but after some time, as the incoming data changes, then the same model may not give uh, good performance, and therefore at that time you have to detect that drift in the model, whether its performance has been degraded or not. And if you find that it is degraded, then in that case you have to take action. So this is the new input data, and the model's performance, new input data comes, drift is detected, then model retraining is done as seen in the top of the diagram. And finally the new model, retraining model, then again development, and again that model is deployed. Instead of original pickle model, now new pickle model will replace it. So this whole process, this right side process, drift detection, that is called model monitoring. So actually speaking, it is ingestion, EDA, development, deployment, and then model monitoring, drift detection, model retraining, again deployment. So it is an iterative cyclic process. And this project will show you how these things can be automated. So the tools which we will be using is Python at the back end, Streamlit at the front end, Apache Airflow for model drift analysis along with Evidently AI, and MLflow for initial model development part. Now this MLflow is a good tool. As such model development we do even in Jupyter Notebook or maybe PyCharm or VS Code. But there you just see the code being executed and the pickle model ultimately being generated. But here in this MLflow we can visually see the model being developed. Not only that, we can see multiple models being developed simultaneously, and they are even simultaneously evaluated also. So various metrics like precision, F1 score, accuracy, they are also displayed simultaneously on a dashboard like thing. So this is one project which we want to discuss. Now here is the code of our project. Before I go further, first some gratefulness I have to express to this particular person, Cornelis Yuda Vijaya. He had written one excellent blog here, and I am qualified data scientist, master of data science, but I have no formal qualification in data engineering. So I was often struggling at that time regarding making this last part particularly, that is model monitoring and automated model retraining. So after this blog, things became very clear, and thereafter I made a lot of further practice also. So you must, if possible, visit this blog, and this gentleman has a presence on uh, LinkedIn also, so you can follow him. Okay. Now let us quickly do. Now very quickly, what we will be doing in this part, because this part I will go very quickly. In fact, I will just click next, because this part is very simple. Here we will be doing this thing. So I have written on my notepad that first part is very simple. Data validation, first data ingestion of course, then EDA, then data validation, null removal, data balancing, and then visual analytics. Okay, so that part I will just show, because with that much part almost everybody is nowadays familiar. Okay, so let me quickly go through that part. Importing libraries, ingestion, and viewing the top rows. We can see that some columns have names, so drop them. only two columns are left. One is the email message itself, and one is the label for that email message, whether it is a spam or ham. Okay. Last five rows of the data set, shape of the data set shows 5, 8, 2, 6 rows, sufficient observations. Data types are both text and target are object. So even the target variable, though it is labeled 0 and 1, 0 for non-spam or ham and 1 for spam, but it is currently text. Then count NA. In the text, there is no NA. Email mode, there are all field. There is no empty. Then this line we have put, drop NA in the text. Even though there are no NA, but when a new incoming data comes, it may contain NA. So therefore, this line. Then this target had 30 NA. So we removed them because we have sufficient rows. So 30 rows removed does not make any difference. Check if all NAs are removed. Add two columns. One is the text length, which is the length of the email, and second is the email words, number of words in the email. Data types. Now these two new columns have integer, but still that object, target variable is object. Let us do data validation. Target variable should have only 0 and 1. So let us try to find some invalid rows which have values other than 0 and 1. And surprisingly, 9 rows were found which had some this kind of random values. So we drop those rows. We have sufficient rows, and now clean data frame is out. Still we have 5787 rows. So that is fine. Convert that target variable into a integer, and now check the data types. So fine. This text or email message itself, that will remain text only, but this have been converted into the integers. For converting this email message into text, we will have to use vectorization, which is in the domain of NLP. So we will see it will also come later on. But now this some visual analytics. Data distribution of non-spam blue and spam yellow remains almost the same, but spam is having skew on this right side, right tail, and that means spam emails are longer. Again, number of word wise, then number of words also in spam yellow appear more compared to ham messages. Okay. Now some data balancing is being done. So first let us count. 68% were ham messages and 32% roughly were spam messages. And we had sufficient rows, so we can do undersampling, remove some rows of oversampled class, and ultimately we made both classes equal. And let us see how many rows are now left. Still 3, 7, 8, 2, more than sufficient. Let us check if we have not disturbed the data distribution in our balancing. We have not, and distribution has remained same. So up to this is actually easy, and our normal students, in the beginning, those who begin in the data science, they do this much: data EDA and data reprocessing. Here I will pause my recording. Recording continues. Now in the lower part there is terminal in the PyCharm, where I will execute a command mlflow UI. So mlflow you have to install first. Pip install mlflow, but that I have already done earlier. So I just click this, and my mlflow will open in this particular port 5000 on my local host. Now with that, so this is my mlflow. I think everybody can see on their screen. Okay. I needed to do some adjustment in OBS Studio because I'm using dual monitor and it is slightly difficult to move from one monitor to another while recording. So here, this is mlflow. Some earlier training was already done, model training and building. So these are some older models. If you want to see all process from the scratch, then let me delete all this. So earlier all models are deleted. Even this name also I can delete. Okay. Now come back to our PyCharm. So in the PyCharm, if you see now what we are going to do, then so now I am again in the PyCharm, and you can see that model development and experiment tracking with ML flow. That is the title here. Okay, so let us do our usual train test split. Let us see whether it is successful or not. So train data set, test data set, things are looking fine. Now we import ML flow and create one experiment. Since this experiment spam assassin underscore email underscore spam underscore ham underscore classify 3 was already created earlier, it might show error. So I'm writing fourth experiment. So it is executed without error, means some experiment has been created. But what is that experiment, where it is saved? Then you can execute this code, and you can see experiment ID is here, and it is saved in. It will be saved in ML flow artifacts somewhere here. Okay, 7.3. This is the number of the artifact. Okay. Now let me define a function which will be using that ML flow. That function is nothing but, as I said, ML flow is what? ML flow is, you can simultaneously use 5, 6 or any number of algorithms. It is just limited by your hardware capacity to train your model. And it will not only train the models and develop the model files and put it in the model registry, but it will also evaluate those models and find F1 score precision accuracy for all the models. So here we are using those models: multinomial, ND, and logistic regression, random forest, XGBoost. Here also these are those models which we are going to use in our ML flow. This is the matrix, accuracy, precision, recall, F1. These are the vectorizers, because our email column is still text. So we know that machine learning models cannot be trained on text data set. So vectorizers are required. Bag of words and TF-IDF, two types of vectorizers we are using. So total 4 models we are trying, and 2 vectorizers for each model. So 8 models will be created in ML flow user interface when I will show you again. This part is okay. This is what matrix we are tracking and how we are tracking and everything. Fine. And then that results are returned as a data set. Here ML flow run ends. This is just a function. So when you execute it, it does nothing, because you have to call that function. So I'm calling that function here. Sorry, this is first some X train is there and Y train, just for kind of verification that whether things are okay or not. Okay. And here I'm calling that function. But this time the function execution will take a lot of time, because we are training 4 models with 2 vectorizers. That means we are training total 8 models. So what I will do here is I will click this, let it execute for a few seconds. It takes around 2 minutes on my desktop. Okay, but and then I will let it running, and I will switch to ML flow window which is open in a browser. If you remember, I deleted all past runs, and all past 8 models were already present, but I deleted. I wanted to show you from scratch. So I am executing this. Okay, and it is running. Now let us try to switch our OBS to that ML flow. Here our ML flow is there. Let me maximize that. Okay. Currently no models are being seen and nothing is being seen. Let me refresh. So here at least this spam assassin classifier is set. And now 2 models are there. One is developing and one is green. So that has already been developed. Okay. After some time, if I refresh, 3 will be there. After some time, if I refresh, still only 3. 4 are there now. It will take some time. 5 are there. Each model takes somewhere around half a minute to 1 minute for development. 6th model, 1, 2, 3, 4, 5, and 6 is getting developed. Seven are developed. So 8th last model is being developed. Okay, I think the process is completed. And now I minimize this window slightly and maximize my PyCharm back. And where we have come in this original architecture with which we started. Okay, so then if you see now, let me still minimize that ML flow window. So okay, we have Done. Now ingestion, EDA, development of model. We have done model development using ML flow. So far we have gone up to this stage. Okay. Now let us go back to our ML flow. So for that, here this is ML flow. The great thing is that it also not only develops the model but calculates all metrics. Okay, so you can compare 8 models based on chosen metrics. Let us select precision. Someone can select F1 score also for a good balance between precision and recall. It depends upon business case. Let us assume that the business was more interested in avoiding false positive. That is when a message which is ham is mistakenly labeled spam by our model, and it is not allowed to reach the inbox because that can be useful business communication and it might lead some loss to the company. So I have selected all models precision, and now if you see, I am just in this column bit. Okay, so you can see all models here. This is the first model, bag of words, logistic regression. This is its precision, bag of words, naive Bayes. This is its precision. This is bag of words, random forest, bag of words, XGBoost. As such, XGBoost here has slightly lower, very slightly, 9962 this has naive Bayes, and this is 9940, so nothing much to choose from them. But ultimately they two were candidates, and before deciding on, this is another XGBoost 9920 or 21 almost, so nothing much to choose. But I also similarly selected F1 score column. Now here I am not taking that time because it will be very lengthy video. But when I found that F1 score column, then I found that considering both precision and F1 score, XGBoost was just marginally better than naive Bayes. So I decided to keep XGBoost. Whatever you get as the best model, that you have to keep. Okay. So here the role of ML flow is over, and therefore its role is for what? Its role is for creating models, and its role is for finding metrics. So here I will pause the video for a few moments. Now, what next? After developing the model, multiple models, and finding the best model using ML flow, next is deployment part, for which we will be using Streamlit. And here I would be using Docker because I want to deploy Streamlit ultimately on a Linux server on some cloud database, cloud provider like AWS or Azure. So currently I am on my local host only, and what if I want to do the experiment on Linux? I am on Windows host. So Docker is the tool in that kind of situation. So let us open Docker, and in that I will have to first cd to one in my PyCharm. I will open another terminal and cd to e2e underscore sum underscore classifier. This directory, this, because my Docker YML file where I want to create my Docker container, what kind of Docker container will be created, all instructions are here. So that is in this directory. So I will use that, and then I will be using two simple commands in that directory. One is docker compose build, and another is docker compose up. Okay, so let me do those two. So docker hyphen compose build. Internet must be connected because it pulls the required resources from the Docker registry. Here this may take some time. For example, here you can see pip install Streamlit, then install requirement.txt. So I have provided requirement.txt file which contains all the things which I will require to run my Streamlit app. So they will be pulled from the internet. Since I already executed once, it is running in a fraction of a second, but it might take some time for you. Then docker compose up, that will create those containers. Okay. And if you see here on the local host 8501, my Streamlit app will be running. Okay. Now here I will have to pause for a fraction of a second and make the Docker desktop the focus of OBS. So here is my Docker desktop, and you can see that my app's backend is created, my app's front end is created, and it is also shown that it is running on this 8501 port. So that much was clear from the PyCharm also. Now I open it, and this is that Streamlit app user interface. In my PyCharm, I have already collected 3 messages. One was Streamlit user interface I will have to bring to your focus. So let me pause. Let us see if Streamlit is visible or not. It is still not visible. Sorry. Okay, now my Streamlit app is visible, and I had already put three messages. One was a spam message, known, because I was given a data set which was labeled. Another was hem message, again known. Its label was 0 in my data set, and another was uh, on the fly created message. So first let me put the spam message, or rather hem message, this is I think, and let us classify. So it is correctly classified as hem. Now let me put another, that is the spam message. Remember, these two were already given, labeled in my dataset by which I started my training in the Jupyter. So there is nothing much. We are just testing. So it is correctly predicted by our model and shown by our this Streamlit. Third is our message which is just on the fly created, fabricated. It is neither in the test set nor in the train set. I just created it that 50,000, you have won some millions of rupees and lottery, and we are willing to give you a loan of so many millions rupees with this much rupees at a rate of 0.5% per annum. Obviously, no financial company will give. So I have deliberately put all the symptoms of a spam message, and let us see if it detects. Yes, it detects. So here, my Streamlit thing or front end thing is over, and I'm closing this window. Okay, and I'm pausing the. Now we will start our recording. We are back in PyCharm, and what that ML flow has done. So we earlier had defined this function. We took 4 models, and we took 2 vectorizers. So 8 models were created. We called that function here. It took some time, but meanwhile we opened the ML flow in the by using ML flow UI command in the terminal of PyCharm, and it showed us models actually being developed one by one, and F1 score, accuracy, etc. You can even define one function to visualize various metrics. That means what you read on the ML flow UI, you can see them as a graph. On the x-axis, iterations are there, and on the y-axis, accuracy, here precision, here recall, and here F1 score. So dark brown color is for XGBoost model, because we have chosen that as our best model, and that you can see here also it is appearing at the top, here also appearing at the top. Here it is initially at the, not at the top, but it reaches after 3 iterations for precision at the top, and here also it is at the top. We create a data pipeline using our best XGBoost model. Actually, role of ML flow was over before that, and therefore we closed the ML flow window. But we need one data pipeline for our deployment process. So we create a pipeline, and this is that pipeline which was created. It had 2 elements, count vectorizer and HDB classifier. Okay. Now we dump this model pipeline as a pickle model, spam classifier pickle, and we immediately reload it, because sometimes dumping creates a corrupted file. So reload it and test it with some model which is hem or what. Actually, we have already done that in the Streamlit. So very quickly, this is actually a message which was hem from the data set only, and it is predicted as 0. Similarly, this is our fabricated message, you have won lottery and all that, and it is predicted as 1, that is a spam. So now Streamlit app is also over, and I even showed it on the user interface. So in this our architecture where we had started, it was raw data, then exploratory data analysis, then model development, experiment tracking. This was done by ML flow. Then we had a deployment which we did on the Streamlit. Backend was in Python. For this deployment was done on Linux, and for that we had to build front end and back end on using Docker. Okay. So now this part only is left, that is drift detection using Apache Airflow and evidently AI. So for that we need further Docker for few more pulling few more resources from the Docker registry. So first I will have to again cd to e underscore spam ham classifier. There is no such directory. Why? Because there is a E2E spam classifier. Okay, only spam classifier. There is no ham. So P2E spam classifier, and again I will have to do a CD to one directory which is inside, that is Docker. I will show that directory in PyCharm. Just wait for a moment. But that is Docker, not Docker actually, but that is here somewhere. If I see it is, yeah, Docker Airflow. In that I will CD to scripts. In that I will CD to because my drift detection and model retrieval, these are located here. Okay, and in that also scripts, there is one folder project spam classifier. So I need to go there because I want to now do that drift analysis. So CD Docker underscore Airflow. Then after that there is scripts. After that there is project underscore spam underscore classifier. So if you do that, I'm in that correct directory. Here I will build first an environment where my Docker containers which are required for this detection, drift detection and retraining, that is my Docker containers which will be having Apache Airflow and Evidently AI. So they will be created. But first I have to create a proper environment. So Docker build -t drift detection environment dot, last dot means create in current directory. Since I think it is already created once, it is finished first. Now next is the environment is created, but I have to then use again Docker compose build. I think we deleted all Docker containers. So let me check it. Let me make Docker desktop the focus. So for that I am pausing this week. Yes, only two containers are there, spam backend and spam frontend, but that are really required for that Streamlit. But more containers we need for Apache Airflow and all that. They are still not there. So let me again minimize this, and we want to pull the Docker containers. So I am using Docker compose build, and then Docker compose up. You can see here it is pulling Redis server, it is pulling Airflow, it is pulling Airflow scheduler, it is pulling Airflow worker, Airflow init, Airflow web server, it is pulling PostgreSQL database, and everything will be at Linux base. I am working on Windows, but my Docker container is Linux base, and it will take some time to pull all this. So I am pausing the video for some time. Okay. Now if you see my same Docker desktop, then you can see earlier only this backend and front end, these containers were there. But now in the Docker Airflow, there is this Redis and PostgreSQL and Airflow and everything. Not only that, my Airflow web server is even running here. So if I click on this 8080 on localhost, then I will get my Airflow user interface. Okay, but I am clicking it, but you will not be able to see it because I bring it to the focus of OBS Studio. So fine, let me pause. Okay, so this kind of Airflow will open on this 8080 port. Username and password both default are 8080, and this is my model retraining whole plan. If I click here, I can see details, what tasks are to be done, then graph. So basically I will do first check for drift. Has the drift occurred? Yes or no? If yes, go to next step. Retrain the decision. Take retraining decision. Do you want to say is the drift significant enough? You can decide some threshold. Maybe say just a drift of 0.1 or 0.01. Don't retrain. But if it is more than 0.5 or maybe whatever you decide, then retrain. So do you want to retrain? So it will be yes, and then start the retraining task. For this also we have written our script, which I am just now showing you. For that I will first minimize this. But this kind of graph is called directed acyclic graph, DAG, and therefore this folder in which this script which handles all this logic, that is also named that only in our PyCharm. Let me minimize this and maximize PyCharm. Okay, and let me bring PyCharm as a focus. So yes, now here you can see there is one such folder in Docker Airflow DAG, and there is this script spam classifier retraining DAG. So it is already here open. Those three tasks which are written here at the bottom also, because they will decide in which order. So first, whether drift occurs or not, that is checked. Then whether that drift is sufficient based on some threshold, that is checked. And then some model retraining will be done. So there will be obviously three functions in this script. One function will handle this part, drift check. So that is somewhere here, condition check. Okay. Then another function will handle this, retraining decision, whether you want to retrain or not. That is here somewhere. Okay. That check test. And sorry, this one, retraining decision. And then last function somewhere will be handling model retrain task. That is this task in which entire model will be created. Of course, this time we will not use all 4 and 8 models. We will not create because we have already found that XGBoost works best. So we will use only XGBoost. But the new model will be developed and it will replace the original pickle model which is in the backend. So here in the backend, original pickle model was there in the app section. This spam classifier pipeline.pickle. Now we will, this when you execute retraining task, if data changes and if you find that the change is more than the threshold that you have specified, then you will execute the retraining. Not only that, this script is automated. So actually this scheduler says that execute this script on the first day of every month. So that means that manually no intervention is required. Every month it will execute, and if the drift is more than some predefined threshold, then it will run this script. Okay. But here I want to display to you that the airflow works. So I will manually run that script. And for that, here airflow should be again made, yes. So airflow is here and it has a provision that you can even manually trigger. So I am manually triggering. Immediately 3 tasks are displayed on the left side. Green symbol indicates they are running, and dark green or something that will indicate successful. Okay. So currently it is running. Graph will show better view. Okay. So whenever this is completed, condition check, then this part will show success. And yes, I have deliberately put one data set which is having different statistical property for our check in our script. That means that the model will detect, or this DSG will detect that a drift has occurred. So this will be successful. This also will be successful. I have already taken the care that the change is sufficient. You can see here it has turned dark green. So that means it has succeeded. Second one has also turned dark green. So that has also succeeded. Third part, now model retraining is going on. So I already know that drift has occurred. I already know that the drift is more than my threshold value, and third has also succeeded. So that means model retraining is over, and as I said, new pickle model is deployed, and you can bet on this that your model's performance, which has deteriorated because of new data set, that is now again up to the mark, and your model is creating business value.